Good afternoon, everybody. Welcome to this afternoon's session. We have Mike Leonard speaking with us today about the complexities of dealing with data coming from a large number of distributed devices. Please make him feel welcome.
Thank you, everyone, for coming, and thank you for still being here as we're getting towards the end of the Sunday. I'm sure some of you are starting to get a bit tired. So hopefully some of you, it looks like 113, 112 of you have gone to this web page already. So what we're going to try and do in today's presentation, this is very much a solution looking for a problem. So I wanted to try and do something a bit different, something interactive, and try and build a presentation where rather than me standing up here doing all the hard work, you can do some of it for me. So this is what we ended up with. So if you haven't gone to sensordemo.now.sh, please do. It's only really going to work on a mobile phone. We make use of the gyroscope in your phone. So if you're on a laptop, it's probably not going to work. So today we're going to be talking about basically taking all these phones in the room, sending data to the presentation. So also, you know how they say live demos are a bit scary, don't do them in a presentation? Well, this entire presentation literally is a live demo. So hopefully everything's going to work well. But I work at Reposit Power, where we're kind of essentially from a technology point of view an IoT company. So we deal with a bunch of issues from dealing with IoT devices day to day. And today we're going to basically pretend that all the phones in the room are little basic sensor collectors, IoT devices. And we're going to send some data up to the slides, and we're going to see how to process that stuff. And we're going to hopefully what I'm going to show you is it's not always trivial to get data from these things, and there's probably some hidden problems there. And hopefully you go away with a bigger appreciation of actually dealing with IoT devices at scale. If you're doing it yourself, then perhaps it'll give you some ideas of things to look at. Just as a quick show of hands, how many people in the room here work in an IoT type company? Oh, a fair few, so that's pretty good. So yeah, if you haven't gone, go to this demo. So what we've got here is hopefully if this works, if everyone starts rotating their phones, they get their phone out. So maybe if you hold it completely flat to start with, and then maybe go to the left, then it's not working. Let's try and slow this down a bit. Just try again. Okay, this is off to a bad start. This is not going to work well. Oh, here we go. So maybe everyone just try and hold their phone directly upright towards them. It should go towards the bottom if you give it a second. Not all sensor data comes in at exactly the same time. So for a variety of different reasons. So in an ideal world, every single device you've got is all sending the data up, and it's all perfectly synchronized, and everything's fantastic. And when you want to get the last second's worth of data, you can just query that very nice and easily. You say, give me the last second's worth of data, and you get everything. But if we're trying to do something such as get a real-time type view on our data, then usually these devices are all sending their data at different time intervals. So it could be that their actual clock is slightly skewed. Or it could be that because of the way you started up software, if everything runs on, say, a 5-second loop or a 10-second loop or an hourly loop or whatever, the chances are you haven't started all the software at exactly the same time. So each of these devices is skewed. Now that's okay. That helps in some respects. That helps with load in your data center, rather than having all the devices all spamming your data center at the same time and basically DDoSing yourself. It's good to have this distribution. But in terms of trying to do things like real-time graphing, it makes things problematic. So we've got this example here, basically, where we've got a 5-second period here. And you can see each of these blue squares here is basically meant to be like a device. And then each red dot is when it transmits data to, say, a data center. So we've gone through the first 5-second period, that's fine. Now we're in the second 5-second period. And you can see each of these devices is sending through the 5-second gap here, and they're sending the same data again or whatever. Now we come in here, and we're taking a look at this data and want to get a real-time view at where that green line is. Now the problem we've got is we just kind of bucket these bits of data up and say take a 5-second average or something like that, or look at a 5-second window for like a real-time type scenario, even if this is an hour or 1 second or whatever, what we're missing here is half the data. This point here and this point here haven't yet got into their second cycle, so we start missing that data. So what we need to do is look at basically some techniques for trying to avoid that. So if we're doing a real-time type view, we could just put a lag in there and look at 5 seconds ago. So rather than perfectly real-time, we could look at a bit of a time frame back. That would give you a nearish real-time solution. Another thing you might have to do is basically do a lot more processing. And to get more real-time, you need to kind of take these values, which you've already got, but then carry forward these ones from the previous period. And that get you a more accurate real-time view. But it's a lot more intensive in processing. So I'm guessing this, yeah, still doesn't work. I was going to show you how that, I was going to show you before and after of how that would work. So I was going to show you basically the problem scenario, and then how that can be resolved here. But unfortunately, that's not going to happen. So this is going to end up being a very short presentation of our demos, unfortunately. But basically, another problem in a similar sort of vein is that if there's an outage of your system, so say you have an outage in your data center or even like an internet outage, something outside of your control. A lot of, when you're dealing with Internet of Things devices, you do see some strange stuff and customers turning off their Wi-Fi or flicking the breaker when they leave. And you have these outage periods. And so one thing you need to be careful of is if you're doing outages on a mass scale and you have all these devices out in the wild and you suddenly block them all off and none of them can send data, when you do bring them back online, you don't want to DDoS yourself, essentially. So if you suddenly start spamming all this data back to your data center, that's a pretty significant load in your data center. And you might basically end up DDoSing yourself. So one way of dealing that, pretty straightforward way of dealing that, is using an exponential backoff type scenario, which I think was previously mentioned with the celery thing. So if every time a bit of data is tried to be sent from the device to the cloud, if it fails, you can basically double the delay and try again. So for each, as you get more and more failures, the time until the next retry gets slower and slower and slower, or longer and longer. If you introduce some randomness in there as well, you can help, again, distribute those things. They're not all happening at exactly the same time. So in those scenarios, that not at the same time thing helps. And then you can try and hopefully avoid DDoSing yourself. So yeah, unfortunately, this has gone horribly. I'm sorry for that. If anyone wants to try and get it working afterwards, we can try and do it just on my laptop. I can try and show you what's meant to happen. But kind of the takeaway is quite clear. This top one, real time is tricky and scale is hard. I think I demoed that very well. Yeah, distributed things are clearly the worst. So please consider these problems. I guess considering the problems now becomes relying purely on a live demo. So consider that problem, and my advice is now definitely do not do that. But yeah, the idea is data collection from distributed sensors and Internet of Things devices is tricky. There's lots of problems to work through, and try and keep that in mind. Any questions? I feel like, oh, there is some. I'm surprised.
Thanks for the interesting demo. Have you tried your demo using maybe a place which doesn't have quite as good bandwidth as we have here?
I don't think that's the issue. It is reaching a connection. I tried in an office with not 100 people. I tried an office with 5 people.
No, I mean really seriously degraded.
Pardon?
Seriously degraded.
Oh, you mean like in the real world?
Sydney Metro.
No, I haven't tried this demo, but yeah, that's definitely an issue with Internet of Things devices. Most Internet of Things devices do connect over the consumer's home Wi-Fi, which is a variable quality. There's things like turn on Netflix as well, which might drop it. And we do get weird stuff, customers turning off their Wi-Fi when they go to bed because it might interfere with their sleeping, or they're just very, very concerned about the power bill. So I think most people are used to managing infrastructure that's a group of servers in a data center, and if something breaks, you just fix it, and it's fine. But with Internet of Things style stuff, these devices are all over the place. You can't have access to them. If they go offline or they break, you're pretty well stuck. There's very little you can do. Just making sure you cater for these types of scenarios up front and build it into how you're operating, and you expect there to be poor internet or no internet or internet that comes and goes or various different things.
You said you're doing this for your work. Can you tell us more about what data you're collecting and what you do with it, and just generally day to day?
Yeah, so so we at Reposit Power, we build virtual power plants. So we take residential batteries, we aggregate them, and we coordinate them basically to charge, discharge into or from the grid. And so we deal mostly with data collection. So there's kind of two aspects. There's the data collection and kind of the monitoring. So we do energy monitoring, pretty similar to the energy monitoring talk we had earlier this weekend, if anyone saw it. We can get voltage and power and frequency. But then also we deal with orchestration and control. So we have flow back the other way. So perhaps we need to take thousands of these devices and ask them to do something all at once. We have to deal with the flakiness in both directions.
You're a very brave man.
Thank you. Brave or stupid?
If I control the client side as well, firing off events from IoT devices, is there anything I can do client side to help with time synchronization issues?
You could. I think for the most part, unless you're dealing with something very, very specific, you don't need things to be perfectly synchronized. Like a second here or there is fine. NTP is obviously a pretty sensible one for dealing with the actual clock time. But like for the most part, in terms of things, kind of data being set up on a schedule, like 5 seconds, 10 seconds, whatever, like it's really good to have that skew. You get problems in the data center, but at least you don't have every second like on the second, or every 5 seconds on the 5 second mark. You don't have all the devices sending data all at once. So you kind of allowing some of that skew in there is a benefit, and you have to deal with it server side.
Hi, I'm interested to know if there's any interesting work going on in the Python community around stream analytics and analyzing telemetry in real time, sort of working with clustering of timestamps and doing those sort of time aggregations that you're talking about here.
I'm not aware of anything specifically Python. We're putting stuff into Apache Kafka to deal with and do real-time stream processing, and there's great Python clients for that. And there's also a few Apache projects, which I think are mostly Java-based. There's Apache Spark and Apache Pig, I think it's called, that can help do stream processing stuff.
Do you have any examples of issues that you faced at Reposit and how you went about solving them?
Yeah, there's loads of little issues, I guess, rather than one big one. There's loads of little things to consider that aren't immediately obvious. For example, it's great. There's an outage. You want to buffer all that data so that when the device comes back online, you don't have a loss. It can send it back up once it's gone offline. So that's easy. You've got a device there. Perhaps you've got some flash storage, or maybe you've got a little bit of RAM you can put things in. That's great. But then let's say the outage carries on for a month. At some point, your flash storage is going to fill up. We use a little Linux device, basically. So if you fill up that flash storage, you can get to a point where things can no longer boot, programs can't start because they can't even have enough space anymore to write like a PID file or anything like that. So there's loads of little tiny things that kind of compound, which just basically add to the whole sensor data is the worst type scenario. This is good. There's lots of questions at least, so we're converting this session into a Q&A rather than a live demo.
I saw you had a slide on how sort of the presentation works. It's really cool. Can you give us a quick overview of how the tech works?
Do you mean how the tech does not work? So there's a Python backend, which is a simple Flask app, basically. And we're using React on the client, both on the phone and the presentation itself. And so in this presentation, there's actually a lot of code baked in there that's meant to be doing graphing and controlling that dot on screen. And then to make everything communicate, I'm using WebSockets. So I don't know how many of you went to the WebSocket talk yesterday or earlier today, whenever it was. But specifically over the top of that, I'm using Socket IO. And for those of you that haven't used Socket IO, I'm planning to use WebSockets. Even though WebSockets are very well supported now, I still would recommend using Socket IO. It's got a lot of really cool stuff in there for handling reconnections and retry, sending data on failures, that sort of thing. It's a really good library. And then there's some, on the phone itself, there's some really weird and wonderful APIs I'm using, some of which I was surprised you can do without permission. So particularly on Android, not so much on iOS. But I'm using a gyroscope API or accelerometer API. You can grab all that data without permission. On Android, you can go full screen from the web without permission. And on Android as well, you can also tell the screen never to turn off without permission, which I was quite surprised you could do all those things without having to ask. On iOS, you can also lock the screen, so from rotation on Android without permission. On iOS, you can't lock the screen rotation, and you also can't tell the screen to not turn off. But there is a nice little hack in there. If you just play some silent media in the background, then it thinks you're playing a video, and it won't put your device to sleep. So that little hack was in there as well. And yeah, for anyone wondering, so Flask, you get a pretty straightforward decorator to basically give you an API endpoint, and you can return some data. So this success is just a wrapper that basically returns some JSON. Clearly, the API was returning success, which is why I was getting those 400s. And then for doing WebSocket stuff, it's very, very similar with Flask Socket IO. And you kind of use decorator to say what particular event and connect and disconnect are there by default. But you can also have whatever named events you want. And you can namespace things as well. So in this little method here, I'm basically saying when I get a connection from the app, then increment the connection counter, but also emit the current state of the application to the presentation. So the app and the presentation itself are namespaced differently. This is stopped 400. How long do I have left?
About 5 minutes.
About 5 minutes. Let's see if no one touch their phones. Let's see if I can get anything going on here. So it is kind of doing something. Let's just reset this. I've got a little reset button here that just resets the state of the whole thing. So if you're currently connected, it will screw that up. There's no errors, but it's still not quite working. Do you have any more questions? I try and answer. And
you mentioned that you were working with Kafka and that there are a number of libraries. Our experience is those libraries vary in quality and stability. I was just wondering what your experience is and if you had a recommendation.
We tried a few of them. I think pretty well we settled on the Confluent Kafka Python or whatever it is library, which is the official one from Confluent who make Kafka. It's a very, very thin wrapper around the C library they provide, but that certainly seems to be the most reliable. It's the most performant as well. Oh. See, it's not me. Oh. Someone's doing it. Let's see if we can. Oh yeah, it is kind of working. Let's see if I can bring this down. So I think it's still picking up someone else's in the audience, I think. So that would take an average of everyone in the audience. I'm guessing some phones are still connected because it's doing stuff, but not to the full extent. So it's probably averaging with someone that's got theirs in their pocket or something. But maybe. What was that, sorry? It's a wild ride. It really is a wild ride, this presentation. So you can see how it's meant to work. I don't think I've got enough time to go through it fully now. Yeah, it's not quite getting there. What can we show? So has anyone got their phone out still? Maybe if anyone's got their phone out, just hold it up like that. We'll see. Yeah, that's not bad. So now I'm just trying to hold it flat. Okay, so this guy kind of working. All right, we can work with this. I've got 1 minute to do the whole presentation again. So what we're trying to show here basically is that if we imagine that all of our devices were sending data every 1 second, which would be lovely, but probably not great for storage or bandwidth or anything really. It's probably a little bit too granular for most use cases, especially things like, say, if you've got a temperature sensor. Temperature just doesn't change that quickly that it's worthwhile doing. So the idea here is what I was going to show is basically what I'll do is I'll stop there for a second. So if everyone has got their phone out, just hold it flat. And then I'll go 3, 2, 1, and just do that with it. So we'll run this. So we should see a low value. So 90 is basically the high value we're going to get. This is average between all devices, so I don't think we'll quite get to 90. But I'm going to stop by pushing the stop button. I've been told to stop. Just as it started working.
Unfortunately, we are out of time. Can everyone thank Mike again? And on behalf of PyCon, I have a small token of appreciation.
Thank you very much.
Thank you very much.
Cheers.